Hi everybody at Prudent American Technologies. I'm Brian Mayerson and I'm an anesthesiology resident at Mount Sinai. Just wanted to thank everyone over there for working extremely hard, extremely fast on this incredible project. So thank you very much. I just wanted to explain exactly what it was that you were working on. So obviously everyone knows about the ventilator shortage that's happening across the country. New York State has received tremendous help from everybody. We received lots of ventilators across the hospital systems. So as of today, we're doing okay. But let's talk about the project that we're working on, just in case there is actually a shortage and we need to utilize every piece of equipment that's available. People are starting to send hospitals BiPAP machines. So this one that we first started to work on is called the ResMed. That's a BiPAP machine. This was given to our hospital by Elon Musk. He's now sending over these machines called the Dream Stations, a little bit more powerful of a BiPAP machine. So these BiPAP machines originally were created for sleep apnea to help with people who weren't properly getting air into their lungs. They were not designed as ventilators. They were not designed to give extra oxygen. They were designed to give room air. So in the back of all of these is an intake valve. This takes in room air, and on the other side, it spits it out. And the tubing goes to the patient's face, and on the face is a mask. I don't have a BiPAP mask, but I have an anesthesia mask. By putting this on, there's no leak in the system. A real BiPAP mask that people wear at home has leak built into the system. With the leak, you have viral particles leaving out into the outside air. So the entire problem with using a BiPAP as it is that it causes aerosolization of viral particles. We don't want that, obviously. So Elon Musk sent these over and said, figure out how to turn BiPAP machines into a ventilator that prevented any aerosolization and for a way to give oxygen to the patient above room air, which is about 20% oxygen. So we took a standard anesthesia circuit, and using just that circuit alone, plus the device that we worked on together, we reconfigured the way that the circuit was supposed to be into a new configuration. So starting at where the air leaves the system, this is the first viral filter that the anesthesia circuit has. Then you have the oxygen tubing attaching to our elbow, and then you have a limb of the circuit. Now the limb of the circuit is connected to a Y piece. This Y piece delivers fresh oxygen and air. Now the oxygen was put in at the port right here. So there's where the oxygen goes into the system. The air flows up here through this yellow tube, through a moisture filter, then through a viral filter, and then this is the patient's lungs. So this would be connected to a tube that's in the patient's lungs. So right now the machine is on, so you can see the bag filling and relaxing, filling and relaxing. So that's the lungs. So which part did you help create? So there's an inspiratory limb going to the lungs, and now the patient has to exhale. This is a semi-closed system. The BiPAP machine allowed leak to come through the mask, but because we can't have leak, because we don't want the virus particle to escape, there has to be a clean way to let air leave the system. So this viral filter is attached to the tube in the patient's lungs. So whatever air leaves the patient goes through the filter and then has to leave our system somehow. There's a second limb. Did you hear that whoosh? The pressure of the system just went from 20 centimeters of water to 0. The cap that you created with the little hole in it pressurizes the entire system. No more leak. Do you hear this soft whoosh? That very tiny leak allows the system to stay pressurized. And that allows a tidal volume or a breath to be given to the patient. So because of your ingenuity, we were able to take a anesthesia circuit, attach this piece to maintain the pressure to deliver breath to a patient. Now, today, because we have enough ventilators, we don't have to use this, but we're not sure what's going to happen next week. The curves look like they're starting to flatten, and if they stay the way that they are, God willing, then we won't have to use this. But we're not sure what's going to happen in the rest of the country. We're not sure who might need this. Having these pieces on standby, send them to any city or state, could be the difference between life or death. So thank you so much for helping to contribute to this great cause.